Yeah, absolutely. So hi, everybody. My name is Zach Babb. I'm the principal technologist at Movil, hence why we were cheering when you mentioned us earlier. And I'm here to talk about digital identity for smart cities. And I found this graphic that sort of sums up the problem in my head. I'm an app developer by training. And so when I see this, my eyes roll back in my head, and I'm like, oh, we're just going to create 50 apps that all talk to each other, and that sounds like a huge mess. And so what I want to talk about is what I hope is a nicer way of approaching the problem of an interconnected smart city. But first, a little bit about Movil. Movil is an urban mobility company making cities smarter. We focus primarily on mobility. There's two divisions of Movil. There's Movil North America and Movil DE in Germany. And in North America, we focus primarily on transit. And so our Movil Transit Suite, I don't know how many of you are local to Portland, but the TriMet Tickets app, we make the TriMet Tickets app, we make the Hop Fast Pass app. We're in, I think, 17 cities in the US. And that's our bread and butter. We make a web experience as well. We make a back office suite called TOMS. We make an inspector application for fare inspectors to check your fare. And down in Orange County in California, we've actually made embedded software for QR code reading on tickets, a product called Fare Connect. And so the use case that we're sort of thinking about, those of you who are here in Portland recently came out with the Hop Fast Pass, which is a smart card implementation, and we were actually the first to put the smart card onto a phone and have that phone be read by validators. And that's a really cool use case because it takes one card out of your wallet. It allows people to use the device that they're more comfortable with in order to get on the bus. Movil is part of, or is owned by Daimler Mobility Services, and Daimler Mobility Services has another group called Car2Go, which you might be familiar with. And so there's a Car2Go app here in Portland, there's a Hop Fast Pass app here in Portland, and the use case is how do you merge the two if you want to merge the two. Wouldn't it be nice to have one experience that allows you to get both on the bus and use a Car2Go? And as we've talked about that internally, one solution is to make what we call a master account. So to actually create an account that works for both and have sort of a joined app experience that allows you to do both Car2Go things and FastPass things. But if you think about that in the context of a larger mobility suite, there might be, just here in Portland, we also have the Biketown bikes. There's rumors that scooters are coming. There's Ubers and Lyfts. There's all these other mobility experiences that you might want to combine into one sort of aggregated app experience. And when you think about getting into master accounts or that would bridge different companies, you sort of run into a problem. So that's the use case that we're sort of thinking about is how can I get it so that I as a user do the least amount of work in order to gain the greatest amount of utility in the mobility space, and how can that sort of expand to smart cities writ large? So let's talk about why existing identity solutions don't quite get us there. Everybody's familiar with username and password. It's a ubiquitous user experience. I don't know, it's basically just how everything works right now. I can't really think of another user paradigm other than username and password. For Movil, what that means is there's a Movil experience that you then put in your username and password. That goes off to some backend, and that creates a session. And a session is sort of a shared secret between the user and the backend that is used to make authenticated requests. And for Car2Go, you have the same thing. So in a master account, you might use the same username and password, but you're still establishing sessions on a one-to-one basis. So again, in that context of mobility, the proliferation of mobility experiences, you don't want to have that one-to-one session and user experience relationship because you're just going to be always limited to more and more complex account management scenarios. People were getting kind of tired of having usernames and passwords for everything, so we went to Google, Facebook, other entities introduced single sign-on. The problem with single sign-on is it doesn't actually change very much. All it does is replace the username and password with one username and password that you can use all across these different accounts. You're still establishing that one-to-one session, you're still establishing that one linkage, and it doesn't work for a proliferation of mobility experiences. All right, so let's talk about a proposed solution. What I want instead is I want to have a single user experience that can make authenticated requests to multiple backends. And I want those backends to be able to proliferate. I don't want to have to establish a new mechanism for making authenticated requests with a different backend that comes along. I want to be able to just add them in as they come along. And the way to do this, as you might have guessed, is with asymmetric cryptography. The Lensfarer was supposed to get a ooh and ah, but if I through asymmetric cryptography, I can use a private key or any number of private keys generated in a single user experience to create authenticated requests along any number of backends. So let's talk a little bit about how that works. Let's see, can I take? I can't take this mic. I'll talk really loud. All right. So the idea is, here's your one user identifier that sort of kicks everything off. It sits here in the middle, and what it does is it tries to create a separation between who you are and what you are. Where who you are is going to be information about you that's used for account recovery, like your name, birthday, any information like that. And we'll talk about account recovery here in a minute. Or passwords or security questions or anything along those lines that would be in a typical account management scenario. The key here is that's separate from any application who's trying to use your identity to do things. Over here, third-party accounts can be created using a hash of your identifier so that the hash itself links back to the identifying system, but it doesn't need to give the third-party application any information about who you are. That's separate. The accounts themselves can hang off information. You can't really stop people from adding that information, but that could be shared amongst these different accounts. And so you could create, so you go back to, well, we don't need to go back, but the point is you can add any number of those third-party accounts at any point in time without actually having to enter in new account information. You can just establish those through the use of a new hash and a new cryptographic key. So let's talk about identifiers. Up here is Facebook's password recovery, where it asks for you to enter your email or your phone number or your username or your first name. So there's all these identifiers that Facebook has collected from you. And then it has at the bottom left, I don't know if you could see, I can't identify my account. So it even has to deal with account recovery in the sense that you don't have any of those identifiers, or you don't want to put them in, or you don't want to share them, or you don't remember what you put, or anything along those lines. In the identifying system, we want there to be one identifier, and we want that identifier to be unique to the system, and we want it to be something that a user doesn't have to remember. And so what we wanted to do is use something like 3 words, about for change. That would be an identifier in the system. If you have 10,000 words, that's 10 to the 12th trillion possible combinations, no problem. If you're familiar at all with what 3 words, which does this for location, this is sort of a who 3 words mechanism for creating identifiers. So third-party account revocation and deletion. Again, these third-party accounts can be added at any point in time. They can also be removed at any point in time by the user. All you have to do is break the linkage between the hash and the identifier. This is a nicer system, or this could be a nicer system based on implementation than what you see in current single sign-on, because there's no need to actually communicate with a third-party account when you actually revoke the account at all. Let's talk about account recovery. So again, I have the password recovery screen here from Facebook. One of the problems that happens in existing systems is they've collected all of this identifying information about you for the purpose of account recovery, but you don't have to use it until you need to recover your account sometimes years after you've put the information in. So for many users, that's not a problem because they know what their name is and they know what their phone number is. But let's say that you're someone who doesn't like giving your phone number out, so you've given a fake phone number at the time of account creation. You might not remember what fake phone number it is that you've given to this account, right? So what we want to do in our identity system is we want to make account recovery something that a user can manage and will remember when it comes up. And so what we want it to actually be something that they might engage in more frequently. And to do so, we want to position it as key generation. So I'm not a UX designer at all, which is shown here, but you could imagine this being a mobile screen where a user, in order to generate new keys, has selected what options they want to have to present. And in this case, it's 2 security questions and their address. By positioning it as key generation, that allows people to engage in it rather than having to remember account information that they might have given months, years in advance, and might have given incorrectly or fat-fingered or things along those lines. At this point, any of these things can be changed. They're editable, they're configurable, and it'll make the account recovery system more manageable by the user rather than just guessing how to do the account recovery itself. All right, let's talk about cryptographically signed requests. So in this system, there's a user app, and the user app wants to do something useful like get on the bus. In one of the smart cities context is, and sort of the thing that I always think about is, what if there's this proliferation of validating computing devices that let you do certain things, right? Maybe get on the bus, maybe order a meal, something along those lines. The validator itself doesn't need to necessarily know how to resolve the request that you're given to it. So as the user app signs a request, it hands it to the validator. The validator might say, hey, I got this request, but I don't know what to do with it, and ship it to some back end. The back end itself doesn't need to necessarily know how to authenticate the request, so it offloads that to an identifying system. The identifying system can authenticate the request, and then the back end and the validator can all resolve what it is that they're trying to do. This mechanism is outlined in a new specification by the W3C for decentralized identifiers, or DIDs. And so if you're curious about some of the high-level implementation details of what a system like this might look like, I encourage you to read up on the decentralized identifiers specification. What I'm advocating for is basically a centralized implementation of that in order to allow for the rolling of keys. That's sort of the missing piece from the did part. All right. Challenges to adoption. Well, one of the biggest ones is that this is my password manager on my Mac, and there's 455 things. So I have 455 passwords. That level of ubiquity is something that would be very difficult to overcome in user experience. I think that's basically the largest challenge to adoption, is just we've gotten accustomed to use username and password since the invention of digital accounts, and it's hard for people to imagine a system outside of that. It might even be uncomfortable for people to have an account-based system that doesn't have a password, even though passwords aren't all that secure. And then the other thing is that in order for this to work, it has to be open. If it's open, then that means that anybody else can do it. If anybody else can do it, then there can be a proliferation of them. Proliferation of them makes it so that you're back to this problem of having all the different accounts in the first place, and you're back to where you started. So that's some of the challenges to adoption. And then, of course, similar systems. My personal favorite is SSH. Using an asymmetric key pair to authenticate requests is essentially what the first line of SSH client-server authentication looks like. That's been working for years and years and years. This is sort of a user-friendly version of that attestation model. And then blockchain. So the way wallets work on the blockchain is through asymmetric cryptography. And everything is very similar except that there's no account recovery for blockchain. So if you lose your private key, you're just kind of screwed. And so this all sort of developed out of thinking about what a blockchain wallet that does have account recovery might look like. And that's how we got where we are. That's all I got. Questions?
So I like your layer, so you do single sign-on, right? JLR actually implemented something recently with their IBI, their head unit.
Mm-hmm.
So you can sign into Spotify or any other apps that you want to consume in the car.
Sure.
So the one thing that might be worth considering is we implemented the card, so you just push a button and I've got my practically publicly pairing and it just logs me in to that central. And then there are derivative keys that go and log you into your individual service. So it might remove that extra step of having to do all that authentication, so username, password,
Sure.
step of authentication.
So that is, what button are you, is that with like a key or with a?
It's a sidecar, so you have a secure element in a credit card form factor and it uses Bluetooth LE.
Yep.
So you can connect to almost anything.
Uh-huh.
And you just push the button. You can actually set it up so you just need your fingerprint ID in the IBI.
Okay.
You don't want to have to go through the extra step.
Yeah.
Really just whatever level of security you want. So a Movable card,
Yeah.
it'll be super easy. I just push a button. I can authenticate over my mobile device or my computer, whatever. And
Yeah.
it's
That basically sounds
streamlined. Yeah.
the same,
Yeah.
except on a card instead of a phone.
Exactly.
Yeah. Cool.
So you're effectively separating the authentication from the data sharing process. Is that fair to say?
So he was creating a mechanism so you could log on to multiple different applications
Yeah.
through one sort of portal where you authenticate yourself to that, which is something similar to what JLR is doing. And we're just using hardware-based security to do it versus having to go through a set of steps to authenticate yourself.
Right.
But that helps solve some of the problems we were
It
talking
does,
about.
exactly.
There's actually a service that they use. There's a sort of I'll call it the authentication service, where all of your apps come through that portal, and it requires you to log in with your private and public pairing and issue a set of derivative keys to log you in simultaneously to all of your apps. I don't know all how it works in the black box, but apparently it's fairly efficient, and that I think that models what you're trying to get to.
Yeah.
Yeah. There was another piece, and I'm sort of blurring the lines a little here, but in your discussion, what I was asking about is the data, because it sounded like you were encrypting the data into the blockchain. And that obviously has a problem just with scalability. But if you are only encrypting the keys into the blockchain, doesn't that help?
Yeah, in this system, it doesn't assume a blockchain.
That was why I was blurring the lines, I'm sorry.
Yeah. But the personally identifying data would be encrypted or hashed and stored in a centralized server that nobody has access to. Yeah, the distributed part of it is simply the keys, the public keys that are used by the identifying system in order to authenticate requests. That's the only thing that ends up being shared.
So you mentioned that you have sort of a single sign-on experience that gets to connect with sort of different applications of it. And if I'm a user that doesn't want to have, a connection where, I sort of want a work account and a personal account, does this sort of account for that sort of experience as well?
It doesn't. I haven't thought about that, but ostensibly you could build it so that any number of identifiers and key pairs exist, right? And then allow a user to manage those however they see fit in order to have work accounts and things along those lines. That's a good point. I hadn't thought about that. All right. Cool.